My name is NURUL QURRATUL AINI BINTI Muhammad ZAHAWAI, Matric number A19A0767. I will explain my part, which is introduction. Statistics is a branch mathematics used to summarize, analyze, and interpret a group of numbers, or other words, analyzing numerical data in large quantities, especially for the purpose of inferring proportion in whole from those in a representative sample. Statistics important because it can use in daily life. For example, the Ministry of Agriculture may use statistics to describe the number of the farmers at every state in Malaysia. First objective of our assignment is to provide a simple and comprehensive references for students on understanding the subject of the statistics. Students need to comprising the whole chapter of statistics, such as measurement of variation, central tendency, and the measure of position. It can help students to understand the theory on real practical. Second objective is enhance the ability of students on interpreting data or any matter related with statistical calculation. The understanding of correlation seems to be quite important, as it can help students to know the relationship between the variables, that is, dependent variable and independent variable. For our assignment, the data we are going to use is estimate number of farmers in Malaysia for year 2017. The data contains 3 different food plants in Malaysia. The data we collect is a secondary data, where the data gathered from the booklet of Statistik Tanaman, Subsector Makanan 2018, prepared by Unit Perangkaan Bahagian Perancangan Teknologi Maklumat dan Komputer, Jabatan Perangkaan Semenanjung Malaysia.
Hi madam, I'm Rajendran son of RAMISH. My matric card number A19A0809. Now I'm going to explain about the primary data into the table form. For our assignment, we use 2 types of variables, which are categorical variable and numerical variable. The categorical variable in this assignment is food plant, and it's divided into 3 types of category, which are coconut, vegetables, and fruit. The numerical variable for this assignment is estimated number of farmers in Malaysia. We collect 42 samples from the data. For the data arrangement, we use the table of grouped data for the table distribution. It was because the observations are sorted into classes of more than one value. To construct the frequency distribution, we find the number of class is 6, which is k equals to 6, and class wide for the frequency distribution is 7204 by using the formula of class wide, which is maximum entry minus minimum entry and divided to the number of classes. So the frequency table has been constructed like this. Second, relative frequency. The relative frequency is the portion or percentage of the data that fall in that class. To find the relative frequency of a class, we need to divide the frequency f by the sample size n. So we will get the total relative frequency amount is 1. Third is cumulative frequency. The cumulative frequency of a class is the sum of the frequency for the class and all previous classes. The cumulative frequency of the class is equals to the sample size n. So in construct the cumulative frequency table, you need to plus the current frequency and previous frequency, which is 30 plus 9, 39, 39 plus 0, 39, 39 plus 2, 41, 41 plus 0, 41, and lastly 41 plus 1, 42.
Hello, madam. Good morning. My name is SASHITHARAN Analaki RAJAMANI. Matric card number is A19A0824. Okay, now I'm going to explain about graph of group data, which is quantitative variable data. So, in business statistics, graphs are a popular way of explaining the relationship in the data visually. For this assignment, we are going to present our data in two different types of graph, which are graph ogive and graph pie chart. So, let's have a look on the table which is used to construct an ogive graph. So, in the first column of the table, we have class. Second column, upper class boundary. Third column, frequency. Fourth column, cumulative frequency. So, let's have a look on the graph, which is we use this data to construct that table. This graph shows us that estimated number of farmers in Malaysia for the year 2017. Y-axis shows us frequency, while x-axis shows us number of farmers, which is the people. So let's move to the second graph. Okay, for this graph we use a pie chart. So let's have a look on the table. Okay, on the first column of this table we have type of plants. Then second column, estimated number of farmers. Third column, relative frequency. Fourth column, we have percentage. And the fifth column, we have degree. Then in first row, we have coconut. Second row, vegetables. And third row are fruits. So let's have a look on the pie chart. This pie chart shows us the estimated number of farmers according to the type of food plants in Malaysia for the year 2017. Blue color on the pie chart refers to the coconut. Grey color on the pie chart refers to the fruits. And lastly, orange color on the pie chart refers to the vegetables. So, the percentage of fruits on this pie chart is 58.66%. Next, the percentage of coconut is 24.49%. And lastly, the percentage of vegetables is 16.85%.
Hi, my name is Ong Li Wen. My metric number is A19A0786. Now, I'm going to present a part of numerical descriptive measure, which includes measures of central tendencies, measures of variation, measures of position, and shape of distribution for our title, Estimated Malaysia for the year 2017. For the mean, we use the formula of total of fx divided by total of frequency and get the answer 7,068.9762. So, the mean of the farmers in different states in the year 2017 was approximately 7,068.9762 people. For the median, we use the formula of lower class boundary plus total frequency divided by 2 minus cumulative frequency before medium class and divide by frequency of medium class times class width, and the median of the numbers of farmers in different states is about 5,079.3 people. The formula for MOHD is lower class boundary plus difference between frequency of medium class and frequency before medium class divide by the answer above plus difference between frequency of medium class and frequency after medium class times class width, and we get the answer 36.5. So the highest number of farmers in different states is about 36.5 people. Measures of variation, including the calculation for range, variance, and standard deviation. Range is calculated by maximum data entry minus minimum data entry. So the range of the numbers of farmers in different states for the year 2017 is 43,223 people. The formula for variance is 1 over total of frequency minus 1 times total of fx squared minus bracket total of fx square divided by total of frequency. Therefore, the sample variance is about 53,766,171.32 people. The formula for standard deviation is square root of the formula of variance, and therefore the standard deviation is about 7,332.5419 people. Measures of precision including first quartile and third quartile. The formula for the first quartile is lower class boundary plus n over 4 minus cumulative frequency before Q1 divided by frequency of Q1 times class width. So, the first quartile of the farmers in different states is 2,557.9 people. The formula for third quartile is lower class boundary plus 3n over 4 minus cumulative frequency before Q3 divided by frequency of Q3 times class width. So the third quartile of the farmers in different states is 8,441.166 people. Shape of data distribution is non-symmetric. It is skewed to the right because mean is larger than median and median is larger than mode.
My name is Sipewan and my matric number is A19A0828. Today I'm going to present the result of SPSS. And for this slide, I'm going to present the part of measure central tendency. And we can see that this slide have two tables. That is statistic table that we found from the SPSS, and another one is manually calculate table. And for the table of SPSS show that the means of the farmer in different states in 2017 was approximate 6,179.3810 people, while manually calculate is 7,068.9762 people. And for the median in SPSS table of the number to farmers in different states in 2017 is about 3,136 people, while for the manually calculate is 5,079.3 people. And for the mode in SPSS table is about 37 people, while manually calculate is 36.5 people. And for the overall between the calculation for of manual and SPSS for medium mean is quite similar, but except for the mode. And for this slide is measure of variations, and this slide also contain two tables. That is statistic table found from the SPSS, and for another table is manually calculate. And for the SPSS table show that the range of the farmer in different states in 2017 was approximate 43,222 people, while manually calculate is 43,223 people. And the variance in the SPSS for the farmers in different states in 2017 was 7,052,9318.973 people, while for the manually calculate table is show that 53766,171.32 people. And for the standard deviation in SPSS table for the farmers in different states in 2017 is 8,398.17355, while for the manually calculate is 7,332.5419 people. And for the overall result between SPSS and the manually calculate table for the farmers in different states in 2017 are not too much different. And for this slide is measure of position, and it's also contain two tables. That is statistic table from SPSS, and another one is manually calculate. And for the SPSS table show that the first quarter for the farmers in different states in 2017 is 1,062 people, while for the manually calculate is 2,557.9 people. And for the third quarter in SPSS table show that 8,385.75 people. And for the manually calculate is 8,441.1667 people. And for the overall result between the SPSS table and for the manually calculate for the farmers in different states in 2017 can be approximated. And for the last slide is shape of data distributions. And for the shape of data distribution in SPSS table for the farmers in different states in 2017 is skew right, which is mean is greater than medium and medium is greater than mode. And for the manually calculate, the shape of data distribution is also the same. And for the overall, the result between SPSS table and the manually table for the farmer in different states in 2017 can be defined as similar.
For the ANOVA analysis, there was a statistically significant difference between the group as demonstrated by one-way ANOVA, which is F equals to 3.853 and p-value is 0.03. This means that we only have 3% chance of finding the differences that we observe in our sample. The null hypothesis is usually rejected if the p lower than 0.05. So we conclude that the mean estimated number of farmers for three types of food plant are not equal. For the Pearson correlation, the R value between estimated number of farmers and type of food plant is 0.312 and the R value between estimated number of farmers and state is negative 0.194. Thus, the estimated number of farmers is associated with type of food plant and state. For the multiple regression, the SPSS output shows the R value is 0.367 and the R square value is 0.135. The constant variable we use in this form is state and type of food plant, and the dependent variable is estimated number of farmers. The R square value is 0.135, which means 13.5% of the variance in estimated number of farmers can be explained by the state and type of food plant. The Durbin-Watson statistic of 1.971 is not too far from 2. For the confidence interval, we use one sample test to find the lower boundary class and upper boundary class of the estimated number of farmers with using the confidence level of 95%. Therefore, at the 95% confidence of estimate number of farmers population mean fall between 3,562.33 and 8,796.44.
Hello madam, it's me again, SASHITHARAN RAJAMANI. Now I'm going to summarize about the conclusion. So, in conclusion, we are able to identify the sources of data and using the secondary data that from the internet. Our group have chosen to use the data of estimated number of farmers in Malaysia for the year 2017 to complete this assignment. We have choose a group data that a frequency distribution whenever observations are sorted into classes of more than one value. There are 5 steps to construct a frequency distribution group data. So, these are the 5 steps. Have a look. Next, for graphical method, the relationship between data has been shown visually by 2 graphs. An OGIF chart was used to show estimated number of farmers in Malaysia for the year 2017, and a pie chart was used to show estimated number of farmers according to the type of fruit plants in Malaysia for the year 2017. From the pie chart, we can conclude that the estimated number of farmers for fruits plants is 58.66%, which is higher than coconut and vegetable with percentage 24.49% and 16.85% respectively. Central tendency is a central or typical value for a probability distribution. From the measure of central tendency, we can get the measure mean, mode and median. For the shape of data distribution, mode, median, and mean shows it is skewed to the right if its tail extend to the right is mean greater than median, median greater than mode. Lastly, for the SPSS analysis, the correlation, which is the value between estimated number of farmers and type of food plant, is 0.312. Estimated number of farmers and state is negative 0.194. Therefore, from this data, at last we managed to interpret it, analyze using several methods to get the outcome. Thank you.